Yes. Now student, we start the exercise 4.2. I hope all of you familiar with the properties that we studied yesterday. Now based on the properties, we have to solve the exercise 4.2. Here in this exercise, we have to use the properties to prove left hand side is equal to right hand side. So question number 7, prove that the determinant, this value of determinant is equal to 4a square b square c square. Now we take left hand side the determinant as lambda. This triangle is called as lambda. Lambda or delta, you can say delta. Delta is this determinant. Now check the right hand side. Right hand side is 4a square b square c square. So take a common from row 1, b common from row 2 and c common from row 3. So a, b, c taking common from R1, R2 and R3 respectively. So we write outside a, b, c. You remember the property. If we take something common, then value of the determinant is multiply. So we take common a, b, c. So we write outside a, b, c. So left determinant is minus a, b, c. B is taking common. So a minus b, c. C is taking common from row 3. So a, b minus c. Now apply R1 plus R2 because our main purpose to make maximum zeros. So when we apply R1 plus R2, then we get 2 zeros in first row because minus a plus a becomes 0, b plus minus b 0, c plus c is 2c. So we get 2 0 in row 1. So expand along row 1. So 0 into the determinant leaving the first row and first column, minus 0 into determinant leaving the elements of first row and second column, plus 2c. So first row and third column is deleting. So remaining determinant is a minus b, a, b. Open this. Then 0 into determinant is 0, 0 plus 2c, ab minus of minus ab. So this become plus ab. ab minus of this 2 product. So this become 2ab. So 2ab into 2c. Multiply with all these 3 terms, we get 4a square b square c square. That is our right hand side. So in this way we will try to prove left hand side is equal to right hand side. Remember this, to solve these questions there is not exactly one method. You can apply any transformation. Either you do row or you do column, or you do either row or column mixing. But try to solve this that you get maximum number of zeros in one row and in one column. And to solve this question, minimum 2 property must be applied before expanding the determinant. This must be remembered. If you did not apply the minimum 2 properties, then no marks will be awarded to you, because before if we did not apply the properties, then also left hand side is equal to right hand side, because that will be the value of the determinant. So to solve this question, you must apply minimum 2 properties. Now come to see another question. Question number 8. Question number 8. Prove that 1a is 1b b square 1c c square is equal to a minus b minus c minus a. I told you earlier our main purpose to make the maximum 0 in one row or in one column, and keep in mind the right hand side. Here right hand side is a minus b. So this gives you the hint that we should apply R1 minus R2. So when we apply R minus R2, then R1 minus R2 gives us a minus b, and this 1 minus 1 gives us 0. Similarly, we also apply R2 minus R3, because this gives us b minus c and 1 minus 1 gives us 0. Remember that आप कहोगे बेटा a minus b minus c, so c minus a भी हम कर लें, R3 minus R1. We cannot do these all three applications together. I told you earlier कि जब भी अब आपने R1 और R2 में चेंजेस कर लिए तो आप R3 माइनस R1 नहीं कर सकते, because R1 में आप चेंजेस कर चुके हैं. So in these three we cannot do simultaneously, because which R1 should be considered before taking the transformation or after. So these three transformation we cannot apply together. Remember this. We will apply only 2, not 3, because here there is changes in R1. Clear? So we will apply only R1 in R1 minus R2, and R2 में changes करेंगे R2 minus R3. We get 1 minus 1 is 0, a minus b, a square minus b square. And in R2, 1 minus 1 is 0, b minus c, b square minus c square. And third row is remain same. Now taking common a minus b from R1 and b minus c from R2. A minus b and b minus c we are taking common, so it should be written outside the determinant. So 0, a minus b we are taking common, so left over is here 1, and a square minus b square is a minus b into a plus b. A minus b we are taking common, so left is a plus b. Similarly in second row, 0, b minus c we are taking common, so left here is 1, and b square minus c square will be written as b minus c, b plus c. So b minus c taking common, so left is b plus c, 1 c, c square. Now we have 2 zeros in column 1. So we expand along C1. In determinant, we can apply row or column. कुछ भी हम किसी टाइम भी अपनी कन्वीनियंट के अकॉर्डिंग कर सकते हैं. So a minus b, b minus c, expanding along row 1, 0, minus 0, plus 1, plus 1, plus 1. So first column and third row, because this one is belong in first column and third row. So these elements are deleting. So leftover determinant is 1 a plus b, 1 b plus c. Clear it? Now open this 0 into determinant 0. 0 into determinant is 0 plus 1. So this will be equal to 1 into b plus c minus of a plus b. So solving this, we get b and b plus b and minus b are cancelled out. So it will be equal to c minus a. So this is right hand side. So LHS is equal to RHS, hence proved. So in this question, our main, whenever we have 1, 1, 1 in one row or one column, we do the subtraction to make it 0 and keep in mind the right hand side. So apply this trick. We try to solve some more question. Now come to the question number 9. Prove that this determinant is equal to x minus y, y minus z, z minus x, xy plus yz plus zx. Here you see there is no 1, 1. But keep in mind the right hand side. Right hand side we have x minus y and y minus z. So always take the left hand side as the determinant delta, determinant lambda. So x minus y means apply R1 minus R2. Y minus z means in row 2 we apply R2 minus R3. So we get y minus z. So apply these two. Remember, we only apply 2, not the third one. Always remember this. So when we apply these two transformations, we get x minus y in row 1, x minus y, x square minus y square, taking z common, y minus x. In row 2, y minus z, y square minus z square, taking x common, z minus y. Third row as it is. Now take x minus y common from row 1 and y minus z common from row 2. We get 1 x plus y minus z, 1 y plus z minus x, z square xy. Now our purpose is to make maximum 0. So R1 minus R2. This gives us 0. So R1 minus R2 we apply in row 1. So it gives us 1 minus 1 is 0. X plus y minus y plus z. So y is cancelled out. X minus z and minus plus x. Row 2 and row 3 are remain same. Now we take x minus z common from R1. Sorry, z minus x. Because in right hand side we have z minus x. So we take z minus x common from R1. So 0. Z minus x we are taking common. So here minus 1 and it is also minus 1. R2 and R3 are remain same. Our purpose is to make maximum 0. So now we apply the column transformation. So we will do C2 minus C3. C2 minus C3 minus 1. Minus of minus 1, this become 0. The column 1 as it is, changes is only in C2. Minus 1. Minus of minus 1 gives us plus 1. So this will be equal to 0. Y plus z plus x. Z square minus xy. And third column is as it is. So we have 2 zeros in first row. So expand along R1. R1 along expand करेंगे. तो x minus y, y minus z, z minus x as it is. 0 minus 0 plus of minus 1. Deleting the first row, third column elements, we get the determinant 1, y plus z plus x, z square minus xy. Open this determinant. Z square is cancelled out. Taking minus common, from this bracket we get the right hand side. So this complete our question. I send you 2 pics of the question. So with this you can solve the exercise 4.2 up to question number 12. That's all for today.